see with that. So we need to end this one. Just ended. Is he doing that? All right. And are you hearing me too? Good morning, class. It's good to see you again. Oh, really? Wow. Yeah, I can see. I've not seen you before, and I've not seen you before. So you guys are welcome on board. Okay, for your interest, my name is Engineer Chidi for software engineering. You are the introduction part. So Engineer Chidi is a software engineer and developer also. You can see the associations and the certifications also. So what that tells you is that you can also look up at some of these organizations and belong to them. They make you a professional more than people that have the knowledge but they are not in any association. For example, this body called CPN, if you are not a member of CPN, you will not get some certain contracts from government. Then, talking about certification, if you don't have certification, some organizations will not employ you also, whether you want to do online work or not. Like this MCITP, Microsoft Certified IT Professional. If you don't have it, it will be hard for you to get a lead role in Microsoft technology company or get a contract that want to leverage on Microsoft's technology. These are not all the associations there are. There are so many other professional bodies. So you choose the one that is relevant to what you intend to or what you are already doing, and then you belong to that one. It helps. So Ninachid is a member of Nigeria Computer Society, a member of Internet Society, a member of Computer Professionals of Nigeria, member in IEEE Computer Society, fellow Internet Governance Forum, Microsoft Certified IT Professional, with 3 schools certified web developer. So in today's class, we are looking at front end. Last week, we looked at those things that make software engineering to stand out. So you see a software engineer is on a superior position to someone who is a developer or a programmer only. We discussed those things, and we said that software engineering is a process. It follows engineering process, and it have engineering principles that if you follow them, you develop a software that is scalable, that is accessible, and that is efficient. Then I'm recapping what we did last week. Then also we talked about software development lifecycle. That lifecycle must be followed for you to develop a software. So that is the introduction we had last week and last 2 weeks. Today we were looking at the front end, and the next week we look at the back end, and that will be the end of the introduction to software engineering. The following week we'll start practicals, whereby you have to come with a system if you have, and it's good you have, but if you don't, you have systems both here in the other lab, and the systems here will be enough for everybody, but it's good you come with your own. But that will be next 2 weeks. So today we are starting something different from what we did last week and last 2 weeks. So what we do this week and what we do next week are related. If you missed that last week class, you have missed software engineering class. What we will learn today and next week, anybody can do it. A programmer can do it, a developer can do it. But that first week and second week, what we learn there is only for software engineers. So for those that are just joining us, you have to go back. Oh, thank God there is a Google Classroom that is being shared today. So you connect to it, go there, get the material, study it, and then do the assignments so that you get familiarized with those topics that we treated last 2 weeks and last week. Today we are starting another phase. We want to look at the front end development. Why it is important is that the software is divided into two, front end and back end. The front end is the one that people see to interact with your software. So when we talk about interface, is the point of access for the people that are using the software. Like this door, I use it as an example initially. The user interface of this door is that handle. So that's where people access this door or interact with this door. The interface for the chair you're sitting is that place that you sat on and where you rest your hands. And so on. So software have its own interface, and that's what we want to talk about today. So we said that front-end development refers to the development of the user interface and user experience of a software or web application. It involves everything the user interacts with directly. Front-end development is responsible for the structure, design, behavior, and content of the software that users see and interact with. Initially, we call this thing user interface only, but later they now introduce user experience. User experience means how did the user see this your software? If I don't have a hand to type on the keyboard, can I still use this software? If I'm not seeing to know where the menus are and the buttons to click, can I still use the software? That is where user experience comes in. So it mustn't just be user interface for normal people who can see and type. What about some people with disabilities? You have to put them into consideration. What about my system that is using this your software? Is it after using it my computer now hangs? Or after using it, I got a lot of viruses in my system? User experience. Is it easy for me to use, or am I finding it difficult to use this system? User experience. So user experience is not just like user interface. User interface is where you put those buttons to click, menus, and pictures and images. The user experience is how did the user perceive it? So when you are building, when you are doing front-end development, you have to consider user experience. It has come to play, it has come to stay. Look at how software is divided. On the image, the blue vertical line shows the demarcation. At the left side, you see front end, and you see the technologies that are powering front end. You have JavaScript, you have CSS, you have HTML, you have Bootstrap. That means if you want to measure as a front end developer, you learn those three languages and they are okay. And you don't need to learn these ones in the front end and also want to learn the ones at the back end. If you do that, you are a full stack developer then. But I'm saying being a front end developer is enough. You don't need to do this and do this. Or you decide to major at the back end. We will do back end next week. And you see the things that are involved in back end development. This diagram is just to show you the demarcation, the relationship between them. That the software has front end and back end. Then at the back end, you also see database. And you see the technologies that are powering the back end. I mean, the database. So you can use MySQL, you can use SQL Server, you can use MongoDB, and all that. We'll talk about them next week. So that's what front end represents, the interface that the user sees and interacts with. Going forward, we said that front end development is a blend of creativity and technical skill. Creativity is very important when you are doing front end. If you want to do front end design, check within you whether you are creative. Creative means, do you do good designs? Are you good with graphics designing? If yes is the answer, please go for front end. You will do marvelously well there. Because it has to do with what the user sees with their eyes. Anytime they open the system, this is what they see. It has to be nice. It has to send a good signal to the brain. It has to be beautiful. So if you don't know how to do design, don't even go to front end because the work may not be appreciated. No matter how good you are at writing code, that creativity must be there. It's important. Like me, I do both front end and back end. But because I'm not very good at graphic design, I used to hire someone to do my front end for me. But I can write all the codes, but it doesn't look nice. My software interface doesn't look nice most of the times if I'm the one that did it myself. So I will do the back end, do all the code for front end, but I will have a graphic person that will help me beautify the front. And that why I'm still going ahead is because I didn't major in front end alone. If you want to major in front end alone, be sure that you can do graphics, you can be creative in designs. I'll take that again from the beginning. Front-end development is a blend of creativity and technical skill. It requires an understanding of design principles. And that is what I'm talking about. User experience and the ability to write efficient, clean code. Mastery of HTML, CSS, and JavaScript, along with modern frameworks and tools, is essential for building interactive, user-friendly, and performant web applications. As web development technology evolves, staying up to date with the latest trends and best practices is crucial to becoming a successful front-end developer. So the front end have a lot of tools that you can use. From me, as an advice, I would say learn only one and stay with that one and keep up to date with that one. There are so many of them. You don't have to try to learn all of them. You'll be putting stress on yourself for no reason. So you just learn one and stay with it. Let's look at the fundamentals of front-end development. We say there are three languages for front-end. Look at them here: JavaScript, CSS, and Bootstrap. So we just want to discuss about the fundamentals. What are they? What do they represent? What are they used for? So HTML is an abbreviation for Hypertext Markup Language. It is the backbone of web content. HTML structures the content into heading, paragraph, link, image, and other elements. CSS, cascading style sheets.
you have to go back home because maybe your connection.
Let me check. Did you check? Sorry, the mic was not sounding. 227. It's been long. No sound. Since 5 minutes ago. So I'm going to go back now. Sorry, you have to go back. The people online we are not hearing us because the device was muted. So we're going to quickly go through what we have said before. So what we said before, for the interest of those online, is that front-end development refers to development of the user interface and user experience of a software or a web application. And we say that initially what we have is user interface only, where you design the interface how you want it to be and you deliver it for the user to use it. Later, they introduce what they call user experience. That user experience have to take care of psychologies. It have to take care of people with disabilities. It have to take care of how people perceive your system, even though you have done the user interface correctly. For example, there are some software that are heavy. When you want to run them on the system, they will hang the whole system. The interface might be looking beautiful, but the person using it, what's the experience like? The person is not happy because it's delaying him. You have to make sure that the user experience is accounted for. There are some persons that they have sight problem. So they'll be hearing me from you. Can you hear me? Okay. So those online, sorry, our device is having some challenge, but I think we have put a permanent solve to it now. All right, so we go on. We are talking about user experience, and we say it is different from user interface, even though two of them work together. You have to make sure that those using your system are not just looking at the beauty, but they are happy using it, and after using it, they maintain their happiness because of the things you did on the system, because you considered their situation, because you build the system to suit them. You can put kind of narration You can put a kind of zoom. You can put all those additions that can help people with disabilities to enjoy the system. That is what user experience is. As we progress, we also learn more of how you can make user experience very nice, especially in terms of making your software load fast. Because when the software is loading very slowly, it angers the user and is a bad experience. Talking about front-end development, we say it involves everything the user interacts with directly. Front-end development is responsible for the structure, design, behavior, and content of the software that users see and interact with. So that diagram there shows us a full software and how it is divided into the front end at the left side of that vertical blue dash line and back end at the right side of it. So at the front end, you see that what they use is JavaScript, CSS, and Bootstrap and HTML. Then the back end have two components, the server and the database. But we don't have to bother ourselves with the back end, but that's what we will learn next week. Our interest is on the front end, and that's where we want you to pay attention. Front end development is a blend of creativity and technical skills. It requires an understanding of design principles, user experience, and the ability to write efficient, clean code. Again, here, there are key statements that we need to take note of. In as much as you can decide to be a front-end developer and is allowed, you have to check whether you have what it takes. It takes a lot of graphic work. It takes a lot of creativity as a gift. There are people that have design as a gift, is in them, not because they learn it. If they design something for you on a system, you will marvel. The way they mix the colors, you'll be surprised. So if you have that skill, please go for front-end design. You will make all the money you want there. We are looking for people that can design good graphics, good interface. They are on demand now as we speak. Because a lot of persons who want to do programming, they usually run to the back end. Do we have any programmer here? If you program, just let me see your hand. If you write any code, only one person. Do you write code? You? Okay. If you interview 10 persons that write code, 8 write back end, only 2 write front end. And that's what makes them to be in demand. You know. So, but what I'm saying is that you have to have this creative nature for you to excel in front end because its interface is what people will see with their eyes. It needs to be appealing. You need to be able to do that. Mastery of HTML, CSS, and JavaScript, along with modern frameworks like Bootstrap and tools, is essential for building interactive, user-friendly, and performant web applications. As web development technologies evolve, staying up to date with the latest trends and best practices is crucial to becoming a successful front-end developer. So here we mentioned some of the tools that we are going to use, HTML, CSS, and JavaScript. And this is how they relate. HTML is the structure. You use HTML to build the structure of the software, of the user interface. We borrowed the word from the builders, like architects who design house. And we say that HTML is like the blocks of the house. You use it to decide, are you building 6 rooms? Is it duplex? Is it 2-bedroom flat? Is it 3-bedroom flat? It is block that you use to show that. You use block to do those demarcations. That's what you use HTML to do. You use it to structure the page. Okay, this website will look like this. When people click here, it will take them like this. This is the form they will fill. This is where image should be here and all that. You use this HTML to do those structures. But if you stop there, The software will be looking as ugly as a house that is not plastered. For you to make the house beautiful, you have to paint it, you have to screed it, you have to put tiles on it, you have to do POP on it. And what you need to do all those things with is CSS. CSS brings beauty to the website or software or the interface rather. It designs the interface, puts patterns on it, put colors on it, make it look nice to the eyes. Why JavaScript gives it a kind of intelligence, a kind of wow in it. It makes it active, interactive. It can talk to the user. It can tell the user when the user have done something wrong, or congratulate the user when you have done the right thing. Like if the event is successful, it will show thumbs up. If you did something wrong, it will show the sign. If you are disconnected from the network, it will show a picture. It is JavaScript that gives that kind of feedback and also creates animation for the user. There's a lot of other things that JavaScript handles. We are going to learn about events here. For you to do front end successfully, you consider these tools: Sketch, Figma, Adobe XD, InVision, Marvel, Azure RP, and so on. And we say you don't need to learn all of them if you are doing front end. And also you as a software engineer who employ and supervise front end developers, don't think that someone that uses Adobe XD is more important than someone that is using Sketch. No. It is not by the name of the technology. It is by the experience and skill employing. Sometimes people look at the promotion online. Maybe Figma has more money than Adobe XD. So they do more promotion online. People will not think that if it is not Figma, it's not any other thing at all. But it's wrong. So consider that. And you can learn anyone that you want. But sometimes it's also good to learn those trending ones. Because some persons that may want to employ you, they are not software engineers that know that all of them are the same. They would only believe on those ones they hear. And if you call the one that is not among the ones they hear, they feel you don't have what they want. Web browser. Front-end code is executed in web browsers such as Google Chrome, Mozilla Firefox, Microsoft Edge, Opera. Is there another one missing? Opera Mini. Browsers interpret HTML, CSS, and JavaScript to render content as a user interface. So this CSS and JavaScript and HTML, they are code. So you just write them the way you're writing notes or write later. After writing it, web browser will get it and now make you to see something beautiful. You can now see pictures, you can now see colors, you can now see forms. It's web browser that does that conversion. Otherwise, HTML and CSS and JavaScript on their own, they are like a MS Word where you type something. After typing it as a code, web browser will now make it better. We want to look at responsive design. So from now on, we are going to be talking about you as a software engineer, as a supervisor of a software team. What are you going to be looking out for? What are those things that they will use to judge a software that you are part of? What is it that will make them know or think that you are a professional? Software pass through you, so long as you're involved and the software come out and it didn't meet international standard, doesn't meet international best practice, It is you that they will call. Just like as the country is doing, everybody is saying Tinubu, Tinubu, Tinubu. It's not him that is doing all the bad things. But because he's in charge, he's being called. So that's how it is. If anything goes wrong in the software that you are involved, it is you that they will hold responsible because you are the engineer there. They won't go and call the programmers because they are under you. They won't go and call the graphic designers because you are supposed to know. You cannot come and say, I major at the back end, that's why. Then why are you a software engineer? Are you following? One of those things you look out for in the software that you are involved in or that you are supervising is responsive design. Responsive design is making the user interface work across various devices, from mobile phone to large desktops. That is what is responsive design. If they look at your software and say, this software is not responsive, that is what they mean. They mean it is not adjusting to screen sizes because there are different screen sizes. If everybody raises up their phone, you will see that our screens are not the same size. And the screens of our phone is not as wide as the screen of this monitor. But we can use them to access the same website. So what now happens? The responsiveness we make it on our devices perfectly well, irrespective of the size. Your software should be able to do that. And there are two ways or two technologies you can use. One of them is mobile first design, and the other one is media query. Now, you use mobile first if you are told that the software will be used with phone. There are some clients that will tell you that they want their software to be an app. They want it to be a mobile app. And that is because they are not in the field, so they don't know. What they actually want to tell you is that they want to use phone to browse their website or their software. They don't have a desktop and they don't hope to have one. They don't have a laptop and they don't even want to use it. But even if they have it, they don't want to be carrying it about. They want a software that they can easily do with their phone. So when you are doing your requirement analysis, you should be able to determine whether this software is actually supposed to be a mobile app, or is the person talking about mobile web? Like, is it that you just want the software to be able to run on phone? Now, if the person just wants the software to run on phone, what you need is mobile first design, not mobile app. Then media query is a CSS technique. What is used for is to design your software in a way that it will have a kind of sensor. It will know the device and then change to that device, the size of that device. It's not like mobile first. Mobile first, you are thinking mobile and you're designing mobile. But this one, you are designing it so that it can fit anywhere, any device. So even if I'm using this phone vertically like this, and I decide to put it horizontal, the software should be able to spread and adjust and also become nice on the way I put it. If I turn it straight, it should also media query does. It makes your software flexible. It will fit into any device, no matter the size, the width, the height, or the orientation you turn it. So you need to make considerations of responsiveness. You have to test it. In any software you build, you have to test it. You want to look at some HTML structures for the web page. We have said already that HTML is for building structure of a website, like the building block of software or website is HTML. That's what HTML is used for. In itself, it has a structural pattern that it must follow. And some of those that you should know is that HTML has head and body. You can say that it's divided into two, head and body. The head contains the meta information that is linked to other files. Like the CSS can link to the HTML through the head. The JavaScript can link to the HTML through the head and other links. While the body contains what you want people to see on the website, such as text, pictures, videos, anything that the user is seeing is in the body of the HTML. Then the one I jumped is the one they call declaration. This declaration helps us know the version of the HTML that you're using. This doc type HTML is an indication that you're using version 5, which is the current version. The one that have ordinary HTML is version 4. They also have the one they call XHTML. Anyone you are using, you have to declare it at the beginning. But you don't need to bother yourself about HTML and CSS and even JavaScript because we are going to do practical on them. This is just for you to see some things about it. HTML also have elements. You can see how the elements, these elements are the blocks, like a block. Like if you go to block industry, where they're molding blocks, those block. Before they now start joining those blocks to form one, that is what elements are. Elements are the blocks that you use to build HTML pages. So these elements now, they have the one that are for tests. If you want to put test here, you put test elements. If you want to put table here, you put table elements. If you want to put image, you put image elements. That is how But that's not responsive. Mm. So all the things I'm doing on my screen, you're not seeing. Yeah. Is it that share full screen? Oh, yeah, that's what I want to do. Task. Task. You cannot see this. I cannot see it. Then check if they can hear me also. Can you hear me? Look, I'm not, because I'm supposed to use this. But they can hear me. They can hear me. Check. So you think your phone is like 2 hours. We are having a mic. Mm. Okay, sorry for that intermission or obstruction. It's lights that went off. So we are talking about the technologies that are used for front end. I would say they are HTML, CSS, and JavaScript. We are looking at HTML just to give you a tip of how HTML looks like. We have seen the structure and we say it's made up of head and body. Now I want to look at elements and we say elements are like the blocks that they put together to form the building. So these elements are what we have here. There is text elements, there is other element, there is image, link, form, and semantic elements. So all these elements are used. When we do the practical, you will see when and how you can use them. So form validation is one of the things that a software engineer need to look out for, whether you are the one doing it or someone is doing the programming for you. There is need for you to validate the form. Form is an element that allow users to submit data to your software. If you don't control what they are submitting, they can submit virus, they can submit harmful codes. More importantly, they can submit what you don't want or what is not useful. Imagine if you are collecting people's phone number with a view to add them to WhatsApp group or to call them, and someone put in 10-digit numbers that is not up to 11. That means you have lost that person. Or you're collecting people's email and someone put what is not email, what is not email address. You can't contact that person. So that is why you need to control what is being supplied to you through form. And that is what we call form validation. For you to do that, you use attributes like required. If you mention that an input is required, the wizard will not allow the person to submit the form without putting that information. It cannot be omitted. If you use something like mean length, it will make sure that the length of value the person is submitting meets a certain criteria. For example, if you are collecting phone number, mean length should be 11, so that the person will have completed the 11 number. Then if the person now want to use 2, 3, 4, that one is now addition. Otherwise, it can contain full phone number at least. So these are some of the requirements that you need to make when you want to validate form. It's very important that you validate form. Like I said, our role is supervisory. We are not supposed to be the ones writing the code. But if you learn how to write code, fine. As a supervisor, you have to make sure that the person writing that code does validation on all the forms. So that is about HTML. Now let's look a brief at CSS too. So CSS is composed of selectors and declaration. Selector is the HTML element that you want to decorate. We say that CSS is for beautifying, is for decoration. Which element do you want to decorate? It is selector that will indicate that. So in selector, you specify the element you want to decorate. You now start writing the decoration code. The element selector have 2 major ways you can do it, or 3 major ways. One is element selector, where you call the element name directly. You also have the one we call class selector. In that case, you group all elements that, if there are many elements you want to have that design, you group them in a class. It will save your time. Instead of calling them one, you call their class name and it affects all of them. And you do class by using dots. Like you can see dot btn means all classes, all elements that belong to btn class. You also have the one we call ID selector. In that case, you are referring to one element and you must call the name of that element. Only that element will be beautified, not the whole class. And to do that, you use hash. Example is that place you see hash header. So that hash header means it is an ID, not a class. But you don't have to bother about some of these code-related descriptions. We are going to learn them, and we are going to do them practical. We are just mentioning them so that you get kind of familiar with some of these technologies. Then we have pseudo class and pseudo elements. So these ones combine CSS and JavaScript to perform actions like hover. When you move your mouse over the object, you focus on it before it can have effect. Another thing that is important to know about CSS is what they call box model. So this box model tells us that every element is a rectangle. It is important that you view every element as rectangle. That will help you know how to beautify it. Just like a block. A block, what shape is a block when you want to build a house? So every element is a rectangle. If you view it in that way, that will help you to beautify it. Another thing you need to know is that there is something called container and something called content. Content is like all the text, all the images that we put on a page. Those images and text, they are not just on the floor. There is something holding them. And that element that is holding them is the content, is the container rather. Why they themselves are the content. If you look at this diagram here, the C is the content, which is something like image, text. There is something holding it, which is this blue line. Now, in CSS, we have what is called padding, which is the space between the content and the border. You can see where padding is, where we have P. You see where the content is, and you see the border, the blue border, which is the container. The gap between them is padding. The gap between the blue line and the monitor is margin, or the screen, that is the hardware. The gap between itself and the container of the content is margin. and the border is the thickness or lightness of the boundary. You can see where border is. This blue line is a border. That green line is also a border. So these are basic knowledge in CSS, but we are going to do CSS, so we don't need to bother about this. But just want us to have some kind of a more in-depth knowledge of what CSS is like, so that you don't just say to do a front end, you use HTML, CSS, JavaScript, and you don't know anything about them. Look at layout techniques that CSS uses to structure, make our websites beautiful. It can use flexbox in the layout, it can use positioning, it can use grid. So whichever one, the website or the page of any software is divided into 12. That 12, you can use it as 12 by using it 1, 1, 1, 1, 1 into 12. You can also combine it, like the one under combined 3 into 1. So those 3, 3, 3, 3, that means it will have 4 sections. The one under it, put 8 one side and put 4 one side. Any website you open, let me see if I can open a website, any website, and see whether there is something you can see in it. Okay, look at this Google. You can see how they divided it. This place now is 3. This place is 9. This is 3. This is 9. See how they divide it. If you open another website, I don't want us to waste time on this. Okay, you can see this guy. 1, 2, 3, 4, 5, 6. So what he did was to take 2 here, take 2 here, and use 8. So the 2 at the left is not being used. The 2 at the right is not being used. All the 8 websites are divided into like that. You can divide it as many as you want, but just bear in mind that the quantity is 12. So you can now work on it the way you want to organize it. We will work on this for you to see. Still talking about CSS, we have what we call preprocessors. So these are the founding fathers of CSS, the existing languages where CSS come out from, the SAS and Lis. You may not bother yourself about them, but it's also good you know that they exist. JavaScript. So JavaScript make a website interactive. It have variables, it have functions, it have data types, it have control flow. These things are what other front-end software does not have. HTML doesn't have it, CSS doesn't have it, it's only JavaScript. That's why it is able to perform intelligent actions. We're also going to learn JavaScript. Now, how do JavaScript interact with HTML? That HTML is what CSS does. It uses selector to select what it wants to decorate. Is it decorating the hedge or the image or the A elements? Just select the elements. But in JavaScript uses what is called DOM to relate with HTML. It doesn't select like selector. It uses DOM to do its own select. Example of the methods in DOM is get element by ID. So those elements that have ID, you can access the ID of that element and then perform action on it. You also have get element by class. If you want to perform action on a class of elements. Listeners. Event listeners are the ones that check for user reaction. So we said that JavaScript adds interaction, makes the software have intelligence. How does it know? Intelligence is about feedback, reaction. If you click, JavaScript should know that you have clicked and give you what clicking means. If you double click, it will tell you what double click means by giving you the action that is corresponding to double click. If you right click, the same thing. That's why if you are using a system, there is a certain time in the life cycle of that usage where you right click, where you click, where you double click, where you drag. All these things are events. They are called events. And JavaScript manages them because it have what we call event listener. It listens to what the user is doing. If you do something that requires feedback, JavaScript will reply to you. So that's why it have that interactivity. Then we have this big man called Ajax. Ajax is auto-responsive. Ajax reacts immediately. In fact, Ajax is the engine for all these other JavaScripts like React, like Vue.js. All of them are depending on Ajax. Ajax is the parent technology. In fact, before they come on board, people were learning how to code Ajax. But nowadays, it's no longer necessary because if you are using React, you don't need to do Ajax again. In fact, people will not employ you if you are writing only Ajax, except they want to develop a platform. So, but you need to know that Ajax is there and the role it plays is very critical that a lot of offshoots came up from it because it makes the system to run without reloading. What we call reload is going back to the server from the database and coming back to the front end. You know, sometimes we just pick our system, our device, connect to a particular website, and we browse. And in our mind, we think that what we are browsing is in our phone. Some of those software are in US. Some of those software you are browsing here, they are in US. The server is in US. The server is in India. Some are in UK. Some are in South Africa. But we are accessing them here because of the speed. But we notice some kind of delays from the server, of which if the software is right here on your phone, this delay will not be there. What Ajax try to do is to remove that delay. It doesn't require a reload for your page. You just do it quickly. So it increases speed when you are using a system. And that's what they are using to build the modern day JavaScripts that we are using. But you don't need to learn Ajax, like I said. Just know that it exists and what it is used for. Those are the basic technologies. But frameworks are coming up. Just like I said about Ajax, we don't need to go back to learning those, permit me to call them crude technologies again. The white man, in his laziness, has been able to create things that will make the work easier, that will make the work seamless. It's just like someone who now want to go back and be learning machine language or learning, all those zero and one for programming. It's no longer necessary because you can write English and it's programming. So that is how it is now. These frameworks and libraries make the work easy. They have already written all the codes in the world and they pack it in the library. So what you now need to learn is the name of those codes in the library. Anyone you want to use, you call the name, it will come up from the library and the code becomes your own. That is what framework and library is. Bootstrap is a framework for CSS. That means with Bootstrap, you write minimum CSS if you are going to write CSS at all. Because everything you want, as far as CSS is concerned, is contained in Bootstrap. And it makes it easier because it's a library, it's a framework already. You also have Tailwind if you don't want to use Bootstrap. But Bootstrap is leading. In the JavaScript, we have libraries like jQuery, we have libraries like Lodash. JavaScript also have frameworks like React. I've mentioned it before. Vue.js, Angular. These frameworks of JavaScript to be very interesting. If you are writing them, you may not have to go to learn HTML and CSS again because the language contains it like a pack. You can write CSS code, you can write HTML code in that same platform. Some persons, some new persons into this ecosystem, they will go and learn React only without having a basic knowledge of HTML and CSS. They will be making their money, it's working. But for a software engineer, it's not good like that. It's better you allow programmers to do that. You should have basic knowledge of CSS and HTML, even if you are not programming in them. I'm saying if you are a software engineer and you want to measure in front end, that's what I'm saying. If you want to measure in back end, you don't have any business with this front end we're talking about, except the role of a software engineer, which each time we meet it, I will mention it. Each time we meet your role as a software engineer in front end, I will let you know. But the one that only front end persons should know, I will just be flowing on that. So I'm talking about those who want to measure in front end. If you learn React, please don't just stop there. Try to bring out some time and look at CSS and HTML a little. You don't need them, but just have that basic knowledge. It helps. The same thing goes to Vue.js and Angular. They are powerful frameworks. And if you learn one, you don't even need to learn the other. That is, if you are a React developer, you don't need to bother yourself that you want to go and learn Vue and learn Angular. What are you going to be doing with them? That React alone is enough. If you are doing Angular, you specialize there. But if you have time, you can look at them because the difference between them is just minor. If you are good in React, it won't take you long to learn Vue or Angular. But do you need them? One of them is enough. Now, this is a role of a software engineer: version control and collaboration. Notice that software engineer is a supervisory role. You don't need to write in code if you are a software engineer, except you choose to do that, because there are already people called programmers who are supposed to be doing that. They are under your supervision. But why sometimes it's good you have one skill, especially if you are in Nigeria, is so that if you don't have a job as a software engineer, you can be using that skill to be feeding, depending when the software engineering role will come up. Or you travel to UK, or you look for online job where you can exhibit your software engineering role. In that case, you don't need the coding again. But as it is now in Nigeria, only one job is not enough. Okay, so we have Git and GitHub. These are version controls and collaboration. Collaboration is if you are working on, if you are doing online job, there are some persons that do online job. If you are doing software development as a programmer, maybe you use React, for example, and you are doing remote job. That software that you people are building can be in Finland, and you are in Nigeria. Another person is in UK. Another person is in Canada. But all of you are building that one software from wherever you are. That's what is called remote job. GitHub is what will help you people bring all those codes together. Those codes that you are writing in Nigeria, Canada, this place, all of them will come together in GitHub. That's why it is the job of a software engineer to supervise those people writing those codes, making sure that their code is coming to GitHub. If you're a software engineer, you must learn how to use GitHub. So, and I don't think you are going to do the practice because we want to give attention to software development. That's the area they want us to do practical. So this GitHub now is your private training. You have to learn it. But the thing is that it's not hard. It has only how many commands? 1, 2, 3, 4. 4 basic commands: git init, git add, git commit, and git push. If you just learn these 4 commands, you're already on your way to using Git. It doesn't do much. What it does is just allow people to push their code. When the code comes, You look at it and then organize it. That's all. And if you are as a software engineer and you are doing software development or programming, you should also learn Git so that you'll be able to do remote jobs. But if you don't know it, you can't do remote job. All these remote jobs, when we say remote job, we mean a job you do from your house. You don't need to go out. That's what is remote job. So as you are doing it from your house, you need to know how to use Git because that's where you'll be submitting your code. So it's a very important technique. Maybe we should also consider learning it alongside the software development because it's important. But you can do it on your own. So they can be used for code review. When we say review, look at what this person have done. Is this code okay? If it is okay, you commit it. If it's not okay, you reverse it to the person to correct, and you keep versions. So you also track issues like bugs, errors, and track the task that has been given to someone. So if we create a branch for you and you're supposed to submit your code, you can monitor how you are working. So that's what they mean by task tracking. Version control can help do all that. So as a software engineer, please pay attention to version control. It is your job. Programming is not your job. You're supposed to supervise them. GitHub is your job because it's a tool that will help you do this provision. Now, what are some of the things you have to look for in a software that you are involved in a software that you are supervising? If you want to shine out as a software engineer, what are you going to check? We have discussed one before, which is responsiveness. Another one we want to look at is web performance and optimization. Or put it another way, software performance and optimization. Your software, talking about user interface, is not just to be beautiful to look at. It has to be optimized. And that is where user experience comes in. How do users experience, what is their experience like after using your beautiful looking software? Does it hang their system? Does it bring virus into their system? Are they angry at the end of the day? Those things are user experiences. And web optimization is one of the ways you can enhance their experience. You can make them happy using your system. There are 3 actions you can take on web software optimization. One of them is minification and compression. Your software has to be small in size so that they can download it on their devices. If a software is heavy, it will take time to load. In fact, there are some software that they will hang, the whole system will hang until they load. That is a badly designed software. You didn't take care of optimization and performance. No matter how beautiful it is looking, if a software is taking too long to boot, users will close it and be doing another thing because people don't have patience anymore. Have you had no time before? Or somebody saying, "Oh, no time." It is a real statement in software usage. When people see that your software is delaying them, they will close it. And what will help your software to run fast is when you compress it. Because what makes software slow is image. And we cannot do without image. If you use only text to design your software, it will load fast. But if you use only text, it will not look beautiful. You have to put images. So you have to compress those images. If you have video, you have to compress it. But there is a challenge here. If you over-compress, they will no longer look nice. They will lose pixels. I don't know if you have seen a video that is compressed beyond how it should be before. It doesn't look clear again. Even image, it won't look clear again if you compress it too much. That's why the second action is lazy loading. Lazy loading will allow you to use that image without compressing, or you compress it a little, then you use it. It will not load until when it is time for it to load. In that case, it will not hold the hardware to captive. it will allow it to flow normal as if it is not there. The image will not load immediately, so that it will not delay the system from loading. Remember that it is images that cause delay in software loading, is image. So if you introduce lazy loading, that image will not load. It will do as if it's not there to allow the website to load. Then it will now gradually load at the background. Another thing that can help optimize your software is caching. If you look at this image, we say that front end is here. This is where front end is. And this place is the back end. Files stay in the database. And this server that is controlling this database might be in US, like we said before, or in China, or anywhere very far from you. The front end is the one that is with you, because the front end is the one you're seeing, is the one that is on your device, is the front end. The back end is somewhere far across Atlantic Ocean. What does caching do? Caching will get those files out of this database across this server and keep them on the front end for you, so that it doesn't have to travel all the way to China to fetch the file you want before you can see it on your interface. Instead, they will domicile on your front end so that you can easily access them. That is what caching does. So if you want your software to speed up, you have to consider caching as one of the actions that you can take to optimize your website. So it stores the assets locally, thereby reducing the server load and then improving performance. What else will you look out for as a software engineer that is doing supervisory role in software development lifecycle? It is web accessibility. After you have checked the responsiveness, you have checked the performance, the next thing you check is accessibility. How can people access this software? It's not everyone that is normal. There are some people that are not like they're not normal, but maybe they are disabled in one way or the other. How can they use the software? In fact, some of the white people, they are not disabled, but they don't just want to bother themselves. They have gone beyond disturbing themselves with small things like this. So they have robots and screen readers that help them access websites. Their own is to put their headset and relax, and the software will be browsing itself, and the robot will be communicating with them what they are seeing. Your system should be able to handle those things, and you have to check it. That is part of the accessibility. There is something called area role, but you meet it in CSS or Bootstrap. They are the ones that assist those screen readers, those users that are not human beings. The area roles, if you add it in your code, it will help make it easy for the robots to access your page and communicate back to the owner, so that whether the person is disabled or the person is too lazy to want to browse or too busy. Sometimes it's not lazy, maybe he's busy. The third-party user can help them access your system. So you have to, take care of those accessibilities to make sure that the system is usable, not just only to. But that is also where user requirement is important. On the first day and second day of this class, we talked about user requirements, how to gather it, how to meet stakeholders. And we said that the stakeholders include all the users. So you have to go to the users and find out who they are. Is there anybody there that we need screen reader assistance? If yes is the answer, you consider it in the accessibility. When you are supervising the software, you make sure that they add these functions. But if everybody that will use it are okay, then you don't need to put it because it will just be a burden for nothing. So it's not as if every software must have it. You only put it when it is required, when you need it. Another accessibility consideration is keyboard navigation. Most persons like keyboard navigation. So you also check how you can add it to your design. If it's mobile app, some persons like press and hold. You press and hold before a pop-up will come, you choose what you want and go. It makes the mobile app less busy than when you fill up everywhere with many, or button. Because the screen is small. It's not like laptop that you can put many, maybe you divide it into two, put many one side. This one is small. If you divide it into two, the remaining space will not be enough. So those are the things you consider as accessibility. If you are browsing and you see image you like, you can use your hand and expand the image, a kind of zoom. Those things are accessibility features. Zooming, um, screen readers, narration, all those stuff, they are accessibility functions. So you check if it is necessary, depending on the user requirements that you have analyzed. If you think they are necessary, you add them. Another thing that a software engineer have to check in a software is user friendliness. How is this software easy for people to use? You have to check it. Reading it from here, they say a user-friendly interface refers to a design that is intuitive, easy to navigate, and simple to use, allowing users to interact with the software efficiently without confusion, without difficulty. Intuitive means that once they see it, it communicates with their brain that this is how to use it. Just like when you are going out of the door, you see the handle. Automatically, you know that if you press the handle down, it will give you access to open the door, even though you have not opened this door before. So that is what intuition. It communicates with your brain. Immediately you see it, you know what to do. Your software should be like that. Once someone loads your software, he should know that if I click here, this is what will happen. If I click here, this is what will happen. Without you training the person on how to use it. There are two key words here, or two key phrases, should I call them that are key to checking user interface, user-friendly interface. One of them is without confusion. The other one is without difficulty. If you capture these two keywords in your supervisory checks, then you have done it. This software can users use it without confusion, like as they see it is very clear. And can they use it without difficulty? There was a software that I used one time. I can't remember the website or the scenario, but I remember the bad experience. In that software is a form. After filling a form and I click submit, I didn't see any sign to show that the thing is submitting. So I keep on clicking on that submit. I click like 5 times before that first one submitted. Now, what happened is that 5 of them submitted, and the owner of the session said, "Don't submit more than one form, otherwise you'll be disqualified." I submitted 5 times, and I can't forget that experience because I'm qualified for that thing, and I was hoping I would get it. You know, it's a training like this, but that one after training they will give money, and that time I don't have cash, so I was expecting that I will get money from. Now I submitted 5 times. So the software is clear, and there was no confusion using it, but it was difficult to use. You must make sure that such thing doesn't happen. If someone click on submit, at least let there be something rolling or something showing that this software is being submitted, than just to stay quiet like that. By incorporating user-friendly interface principles, we help users feel more comfortable and confident while interacting with the software. Software principles. What are some of the principles that a user-friendly interface should have? Number one, you have to keep it simple. Don't make it too complex. Make it easy for people to see where to click and where to type in values. Use consistent colors and fonts. In software development or in front-end design, there's something we call color theme, THEME. That theme is a set of colors that work together. If you are developing any software, it's better you define your color theme so that you don't just bring color riots into your design. There are some colors that affect the eyes badly. So if someone is using your software and continue to use it, the person will start having eye problem. And that is user experience. Even though the thing looks beautiful, but that color mismatch is harming the person that is using the software. And that is something we don't want. So for your software to have friendly interface, you have to consider the color you're using. Another one is to use high quality images. So this may seem contradictory because we say compress the image. But remember that there is lazy loading that will help you not to overcompress. Instead, you lazy load. It's better than compress. Thank you. Then use familiar icons and buttons. So icons must correspond to what they represent. If you are doing email, you put envelope kind of icon. If you are doing user, you put a human picture icon. If you are showing engineering or process, you use what the gear, that gear sign, like two of them, cogs. That's what they call it. So use icons that represent what you are doing. Don't put icon that is showing a different thing. It's just like someone that is driving. You are navigating this way, but you are going this way. You are confusing other road users. And in fact, it's a traffic offense. That's how it is in software engineering, in user interface design. Your labels and icons must represent what they are. You don't show a different thing and do a different thing. Make sure the app is responsive. We have mentioned it. Responsiveness. Who can remind us what responsiveness means? If you say that this software is responsive, what does it mean? Yeah. It means it will be adaptable in all screens. Thank you. What's your name? Daniel. Daniel is a wise person. Okay, so that is it. The app must be responsive and so that it can fit on any device. Then lastly, test that app before you launch it. Don't say that, it's engineer that I hired now. Engineer can, any code you write is perfect. You are making a mistake. Even ChatGPT will tell you that you should review what they did. Who is using ChatGPT here? Who is ChatGPT? I saw only few hands. Does it mean others are not using it yet? Are you using ChatGPT? Are you using it? Are you using it? Huh? No. Auntie, are you using it? Are you using it? Are you sure? If you have not started using ChatGPT, make effort to start using it. It makes life easier. So what I'm saying is that you have to test even what ChatGPT gives you. Don't copy it and paste. Read it and make some corrections. So the same thing with code. After writing the code, you have checked the responsiveness, you have checked accessibility, you have optimized it. Please test it before you can host it so that you'll be sure that it is actually giving what is intended for. We want to look at these things more critically, keeping it simple, consistent, high quality, and all that. First of them is simplicity. How do you make your software simple? You minimize the design. Do not cluster it. Don't put too much things at the same place. Make it simple so that people can understand it. And again, don't add what is not needed. There's an example I gave here. There's one organization I was doing their membership platform. And when they are designing the form, the man was collecting a lot of information. I'm talking about this place that say present only what is essential to the user's task. Don't overload the users. Now, in that form, the man want me to collect the name of the this for intending members, those who want to join them. So you give your name, your first name, your last name, your middle name, your maiden name, the name of your spouse, where you work, where you live, your state of origin, local government of origin, village name, house address, work address. It's over 100 items he's collecting. I told the man, sir, what are you going to do with all this information? Because you just want to see the person that want to join and judge him. How does his wife, that's the spouse, his village, how do they join to what you want to do? So we have to argue it throughout that meeting before the man can agree that, okay, minimize it. And I have to minimize it. Just give us your bio, give us your academic qualification, and why you want to join us. That's all. So don't overload users. They'll just get tired. We are talking about user friendliness. We want something that users will use and they are happy. We're talking about user experience. Clear labeling is important. We have talked about it. Don't navigate this way and you are going this way. Is all. Intuitive navigation. Of course, users should look at the work and know exactly what to do. They don't need you to teach them. Responsive design. You have to make sure that the software adapts to the screen that is meant for it and make it load quick. Don't waste people's time. Visual appeal. It must be nice looking. In fact, some people think that user interface design is all about nice looking, and they are right. That's why I say if you want to major in front end, make sure you have a skill on design. Make sure you are good at design. Anything you design looks nice. Otherwise, people may not be hiring you. But if you do a very nice design, even if you didn't major in any other aspect of software engineering, you can stay on that front end alone. And people will always call you to come and work for them. Because a lot of persons are doing back end, ignoring front end. And that makes front end a hot market. But you have to be good at design so that what you design will have a good visual appeal to the people. Feedback. For you to have a good user interface, there must be provision for feedback, and that's where JavaScript comes in. So there have to be error messages, there have to be interactivity. The system have to talk back to the person using it. If the person make mistake, let the person receive an alert or information box that, so you've made mistake here. Like that experience I had filling a form that I was warned not to submit twice. Assuming there is a feedback that says, hold on, your form is submitting. I won't click that 5 times. And who knows, I may have gotten that money.
Sorry. Well, how many of you have emerging technologies and this is your first time for you? Emerging technologies, first time. Please, join us outside. Okay? If you're emerging technologies and this is your first time coming, please join us outside. Okay? A lot of software. Alright.
All right.
So we're outside here for emerging technologies. Okay?
We have only 2 slides, so you can just hold on for the 2 slides. All right, so the feedback means that the system should have a way to talk to the user so that the person will know what is happening inside, either as error message or information box. Then accessibility is also important. How is the person accessing the software, especially if the person is disabled? You have to make provisions for screen readers, zooming, narrations. Narration is the one that instead of having letters and words here, it will read it like sound, like audio recorders, audio readers. Handle all that. Then the last of them is user-centric design. Before you develop a software, the first software engineering process is information gathering, user requirement analysis. You have to go to the user and find out what they want. And as you are designing it, you have to design it with them in mind. Even as we are talking about accessibility, you have to know who the users are. If there is no disabled person among them, you don't need to waste time doing all this other extra screen reader and zooming and narration stuff. Just design normal software and go. But if there is any or some of them who are in that class, you must do this. That's why it's user-centric. You don't design it for you. You are not the one that will use it. You do it according to the person. My favorite color is blue. But if I'm doing a software for you and you didn't tell me the color to use, I will use blue. But I can be doing a software for somebody and the person will tell you, I like green, use green for me. It is their own. So you have to design it according to their own. Don't try to convince them, okay, use blue now. Blue is better. It's better for you because it's your favorite, but that's not his favorite. So your design must be according to the users, not you. So, and that's where customization also comes in. The user should be able to customize it to suit them. Maybe you have a kind of color palette where they choose the kind of color they want, where they choose the size of font they want, depending on their eyesight. So all those things are how you can make your software to be better. So in summary of what we learned today, we've said that user interface is where, or front end rather, is part of the software that the users will interact through for them to access the software. You have a whole body of software. For users to use that software, they must pass through the front end. And that front end is where we have the user interface. And we say that nowadays, we are no longer only interested in the user interface design, like how beautiful it is. We are also interested in user experience. What is the experience of the person using the software? Is the person happy? Did you make the person to miss opportunity because he's using your software? Do you make the person's system to hang, get virus, or crash just because he's using your system? No matter how beautiful it is looking, user experience plays a major role as far as front-end design is concerned. And we mentioned some tools that you will use for that. And we say you don't need to learn all the tools. Just pick one and you are good to go. If you also know two, fine. If you are hiring, any tool that they know how to use is okay. So long as the person have good experience and good skill using it. We also say that those that should major in front end are those that are good in creativity, those that are good in designs. Then finally, we mentioned those things you will look out for as a software engineer when you are supervising a software. One of them is accessibility. One of them is, can you mention them? I don't want to mention them again by myself. Mention one of those things you look out for as a software engineer supervising software development. One of the things you look out for is what? Responsiveness. Is the software responding to screen sizes? What else again? Software optimization. Is the software loading fast? You have caching. Yes, it's one of the things that will make the software load fast. So you also look at the user friendliness. Is it easy for the person using it to use it? So these are the things that we discussed today. And then it has a kind of assessment, a feedback question. So I want to talk about the last 2 weeks, the assignment has been given. The material is there on your platform. I discovered that there is a WhatsApp group that all of you should belong to. Is it true?
Yes.
So if you're not on that WhatsApp platform, before you go to the Meet Me or Meet Emma, we connect you to the platform. So there they have shared the Google Classroom link. That Google Classroom contains the files and assignments for you. All the course materials that we are using for the training, they are there. So you download them and go through them. For the assignments, let me see if I can access it from here. Gmail. For the assignment, you have 2 assignments there. One is theory, the other one is objective. You can answer anyone you want first and answer the other one. But you must answer 2 of them before next week Saturday. After next week Saturday, the platform will close. Then that platform we are using, cbtng.com, it has some kind of malpractice check. Because we are not going to be there when you are writing that test. That platform will give us the image of the person writing the test and the video of what happened when you are writing it. So what it will do, it will ask you to put on your video. It will pop out on your screen. You have to accept. If you say no, it will still allow you to write the test. But your result will not be used. So when it asks you to put your video, you say yes, you approve it. Then it will ask you to snap yourself. You see a place to click. It's not as if it's very intuitive. You see it. You just click, and your picture will be captured. Then you proceed, and the video will be showing till the end of the exam. So make sure you activate those things. Otherwise, the system may not score you. Even if the system scores you, you may not access it because you don't have the picture of the person that writes the exam. Then today's class material is there at the Google Classroom. The last 2 weeks and last week material is also there. So if I'm in your shoe, what I will do is to download the material for last 2 weeks and last week first and study it, maybe between today and tomorrow. After studying it, okay, some people are already on that platform, on the Google Classroom. So after studying it, you can now start writing the tests. You can write the test only once. That platform will not allow you to write twice. So if you just write it once, that's all. Then after writing the 2 tests, you can now download today's class, maybe around Thursday, and study it so that you can do the assignment too, today's assignment, and then submit next week Friday, next week Saturday. Yes. See it here. Someone was saying, please, how can I shoot the question? See classwork here. So you click on classwork and you see it. But for you, you do not even need to click on classwork. It's here. If you come to this platform, those are many people have written something. If you scroll down, you see them. Are you seeing it? Scroll down to the bottom. You will see it. This is the first assignment. This is the second assignment. This is the material for that last 2 weeks. And this is the material for today. Yes, so you download them and take the quiz. I said this thing last week, but let me also say it again today. This software engineering is a 3-month training paid by World Bank. To them, every day is class. You're supposed to be coming here every day and stay like from 9 in the morning to 4 in the evening. But we look at it like some of us are no longer under our parents' care. We are now fending for ourselves. Some of us even have family. So we are not only fending for ourselves, we have people we are fending for. So telling such a person to come and sit here morning to night until 3 months is not realistic. That's why we now keep it only on Saturdays. But this course should take you every day of the 3 months. Any day you skip, you have missed something. You're supposed to bring out time from your timetable. If you don't plan to fail, or rather, how did they say that thing? If you fail to plan, you must be the one to do the planning. Don't say that you don't have time. All of us have time. What takes our time is what we think is more important. So you must prioritize this class. Every day, you bring out 2 hours for it. My own 2 hours may not be your own 2 hours. You can choose between 4 and 6 in the morning when the people that will disturb you are still on their bed. You wake up at that time and look at your software engineering course. Or you do it 10 to 12 when anybody that will disturb you is sleeping. You wake up and do it. Sometimes too, you can wake up between 3 and 5 in the morning and do it, and depending on your own time. Some persons that work can also use the work office break time, maybe 12 to 1 or 12 to 2, depending on the break time. So you decide the time that works for you, but make sure that every day you are studying. If you make yourself a Saturday only student, you will not do this course. But this software engineering is 6 years in university or minimum of 5 years in university. But you want to do it under 3 months. And you know that in university, you go to school every day. And they do it 4 years, 5 years. And you want to do it under 3 months. And you are not also reducing it to only Saturdays. It will not work. Are you guys following? So if you don't have a timetable yet, as you're going home, as I'm saying now, and you're thinking now, you already know your best time. Once you go home, put it on your reminder. At the beginning, it's hard, but as you continue to do it, it becomes easier. You make sure that every day you look at software engineering. Don't limit yourself to what is here. That's why I'm asking if you know ChatGPT. You can ask GPT any type of question you would have asked me as you are reading it. You see something you want to know more, you ask. You have to put interest. Because it's a graded course, we are going to score you, like the test you're going to take. We're going to score you. That is just ordinary test. You write the exam, and that one will be physical, and we have to manually supervise you and send your result to them. It is those that qualify after the training that will get the benefit of the training. And there is no IM in it because the people that you are dealing with are big people already. You can't give them money. They already have money. You don't know what you give them. So so you have to make efforts on this. But one good thing is that software engineering is easy because it's relatable to what we see every day around us. It's easy to remember. The logics is just very, if you are sound in your mind, you even know it. Because if they tell you the engineering process, you will agree that yes, this is how it should be. Because we are already using systems. So it's not a hard thing. You can learn it. But you have to put time and effort to learn it. That is the message. So thank you very much from here. If you have question or something you want to say, the floor is any textbook for this. Who can answer that question? Do we have any material for this class? Where will he find it? Are you in the WhatsApp group? So you shouldn't ask this question now because it was this morning that they posted it on the WhatsApp group that you should go to Google Classroom to get the materials. And I'm on the Google Classroom. I just opened it to show you guys where to get it. So the answer is yes, there's material. And you can get more from ChatGPT. I also said it now. Whereby there is a particular thing you're reading and you want to know more on that particular thing, you ask the AI, it will tell you. Or even Google, no, browse it, normal browsing, you will get it. The knowledge is open. Yes, do we have any other comments? Yes.
I actually do the tools of coding. I came because when I did software engineering, I went to you understand. So when you say software engineers, classes will use that kind of terms of things, you understand. So I'm also looking at aspects like when you say what are you trying to say like I'm going to code.
Okay, I understand your question. My name is Chidi, but they call me Engineer Chidi. I'm not a mechanical engineer or a builder. I'm a software engineer. That's where the engineering comes from. And if you look at the qualifications I put here, these are organizations I belong to, and majority of them, in fact, all of them are software related, or let me say IT related. That means that I'm really a software engineer, both by academic and by practice. So I do coding too. I do front end and I do back end. I've also said it here. Now, I didn't condemn someone being a programmer or writing codes. In fact, I also said it maybe in this class or the other class that what World Bank want us to do in this software engineering class is software development. That's the aspect they want us to do. Because, like I said, and like you noted, software engineering is not only coding. It is not necessarily coding. Coding is just an aspect of choice. For those that are here on the first day, can you mention some of the roles that a software engineer can go in case you don't want to go into coding? DevOps, Scrum Master. So there are many aspects that you can go. Quality assurance. So it's not only software development. But why we do more of software development in Nigeria here is because most of the time we don't get that software engineering job. We don't have companies here or much companies here that can employ us as software engineers and give us software engineering role. Software engineering role is supervisory. It's supervisory. It's more on management. That's why on the second day, I advise that some of us that want to major in software engineering, not necessarily the coding part, should take a personal training on project management because software engineering is more on management than skill-based like coding and front end. So while you are a software engineer and you can code, it's an advantage because if you don't get the software engineering role, you can get software development role, and that is double job for you. Yes, but software engineering is not software development and it is not programming. A programmer is just an aspect of what software engineering is about. In fact, a software engineer hires a programmer to come and program for him. We have 5 steps or 5 processes in software development life cycle. 1 is requirement gathering. 2 is system designs and analysis. 3 is implementation. Both developer and programmer, they feature in implementation only. Then we have other ones like testing. Testing is where quality assurance as a role in software engineering is. There are people that their own is just quality assurance. That's what they do in their company. As a software engineer, they don't code, but they make their money. We also have DevOps. Have you heard of DevOps? DevOps earn more money than developers in every field. Since you have contact with some software engineers, ask them about DevOps. If you are a DevOps, you earn more money than a developer, a programmer. But as a DevOps and as a software engineer too, you cannot not have knowledge of coding. Even the class we have today, you see that we're mentioning some terminologies that are in coding. So you have it as a knowledge, not like you be a novice and say you are a software engineer. No, you will have the knowledge that this thing exists and this is how it should be. But you may not necessarily be the one doing it. That is what I mean. I didn't mean that if you are a software engineer, you don't program. No. I say you don't necessarily have to be a developer. There are other things you can be. There are other things you can be a US UI designer, even though you are a software engineer as a software engineering as a profession, but you major in US UI design. If that is where you have skill, is allowed, but you have knowledge of other things. You can also be a developer and you have knowledge of other things. But developers earn more money here. That's why you see a lot of people being developers. But that does not underscore it. If you travel out of the country, or if you're working abroad, or even if you are here and you're doing remote job, any other aspect of software engineering can give you money that is not coding. So that is what I mean. So don't be discouraged. As a developer, you are on the right track. All right.
There's a question on that.
Okay, what is the person else? Okay, this guy is answering that question I asked. Dure Bemi said solution architect. So this guy don't need to code. He's an architect, he's a software architect, he don't need to code. A tester or quality assurance don't need to code. A DevOps person don't need to code. Project manager don't need to code. But developer can code, programmer can code too. So coding is not bad, but that is not the software engineering is not coding. Coding is just an aspect. Suleiman said, software development and engineering, are they receiving the same lecture at the same time? Maybe I'll use a diagram to explain this thing. I don't know. If we have time, let me just paint. Is the job of a front end to design the layout, or is it done by UI UX designer and put into code by front end? Yes, a UI UX designer designs it and then a front end person codes it. But I don't know why you are separating them. A UI UX person is also a front end designer. I mean, he's a front end developer. All of them work at the front end. It now depends on where each person wants to measure. For instance, if I'm using React, JavaScript, I don't necessarily have to learn CSS and HTML. They are already included in what I'm doing. So that is how it is. But from the question you asked, yes, a UX UI designer does the layout, and the one you're calling front end designer or developer now codes it. The person that codes what a UI UX person does. Is that the question you're referring to?
Yes.
Okay. So I want to explain something like this. It's like an organogram. We have software engineer. It didn't fit into that box. Okay, let me put it here. So as a software engineer, you can choose where you want to measure. Because you are to supervise all these people. You supervise the developer, you supervise the UI UX designer, these are the people you supervise. So I'll put these ones under. Who else do you design? You also supervise the graphic designer. You supervise this person too. But you can be a DevOps, you can be Scrum Master, you can be a project manager. Then you supervise these people. So I think this is a way I can explain it. As a software engineer, you can be a DevOps, you can be a Scrum Master, you can be a project manager. You supervise the developers, you supervise the UI UX person, you supervise the graphic designer. That's why in a big company, only you cannot do front end and do UI UX and do back end. You measure in one place, another person is doing another role. Someone is supervising you people to make sure it is working well. That person is the software engineer who can now assume a role of a DevOps. So he cannot be supervising you as a DevOps person. Not you may not call him a software engineer then, but that's what he is. But the role he's assuming is DevOps. He can also assume Scrum Master. He can also assume project manager for that IT project. Then any name that he assumes, he'll be supervising the UI UX person, he'll be supervising the developer, he'll be supervising the graphic designer. His role includes making sure that there's documentation, all the software development lifecycle. He will see that they are followed. That's why I say it's more of managerial than skill-based. But if you have a skill, you have advantage. Because if you're a software engineer, for example, and you don't have any software engineering job and you don't have any skill, you will stay idle. But if you are a developer, even if you didn't get this software engineering role, you can be working as a developer, even though someone is supervising you, but you'll be getting money. Or you can even get your own contract as a software engineer. You get your own contract. Someone will call you and say, develop a software for me that will do XYZ. You charge them and do it and supervise yourself. There are two software developers. One is someone that is a software engineer and is a software developer. Two is someone that went and learned programming. The difference between them is the difference between a mechanical engineer who specializes in auto mechanics and someone that went to auto mechanic and learned how to repair cars. That's the difference. Someone that is a software developer by learning, what the person can do is write codes and deploy it. Maybe if it's a web-based code, he write it and put it on and host it. Or if it's a mobile app software, he do it and put it on Google Store. That's what he does. He doesn't follow engineering process. He's a developer by skill. But if you are a developer by software engineering, you will do documentation. You will do design. All those software development life cycle, you follow it. Even if it's a personal job, you follow it. And when you follow them, you will see that your work will be better than this person. And you can charge more. If it is a bidded work, that person that is just a programmer or a software developer by training, the one he bid and the one you bid, that will be different. And if they call you people for interview, what you will say and what you will say will not be the same. And you will definitely get the job because you will say more than, okay, imagine if you guys just want to train you on how to write code. Some of these things we are mentioning, you wouldn't know them. But you can code very well. We are going to spend 1 month talking about software engineering without coding. We are going to code only 2 months. So if we are not talking about software engineering, we put these 3 months in coding. So you will be a better coder, or you will spend more time in coding. But if you come out, you are just an artisan with codes. Unlike what we are doing now, you are receiving the intellectual knowledge of what software engineering is, and you will also have to code. So there's a difference. Still dwelling on your question, but I think you can understand the difference I didn't condemn developer. I'm a developer, like I said. I didn't condemn, but I said coming from software engineering is better if you want to be a developer than learning it as a skill. So you're not wasting your time. All right, I think that have explained it more. Any more question? Because the class is ending. All right, thank you very much for having me, guys. Let's meet again next week. God's willing. Try and do that assignment and also read up. Create timetable for yourself and try to keep it up. Thank you and have a nice weekend.